Motion matching in Unreal Engine is a query-based animation pose selection system which can be used as a dynamic alternative to state machines and blend spaces. Friends, in my opinion, state machines are still the best choice for many kinds of projects. And at least while the motion matching plugins are still in the experimental status, and while there is a lack of documentation related to motion matching, most companies and projects are not going to switch to motion matching. But why not try out motion matching and see if it works well with your project? It shouldn't take too long to test it out. So, in today's tutorial, we are going to implement motion matching in a fighting game created with the help of the true fighting game engine for Unreal Engine. Let me remind, the true fighting game engine is my project for Unreal Engine that allows you create your own AAA class fighting games. You can easily add attacks, combos, and hit animations, import characters based on any skeletons, and create either single-player or multiplayer fighting games. You can check out my other tutorials in this playlist to learn how to do all of this. And with the true fighting game engine, you can create either Mortal Kombat style or Tekken style games depending on your needs. You can find the link to that project in the description below this video. So, let's start with the tutorial. I have already created a new true fighting game engine project. Let's really quickly switch it to... I have created it for Unreal Engine version 5.4. Let's switch the Unreal Engine version to 5.5. And let's run the project. But meanwhile, we want to create a Lyra project, so I'm going to launch my Epic Games launcher, because we are going to get animations for our motion matching from the Lyra project, right? We could actually get this animation also from advanced locomotion system or from game animation sample project. They work just fine as well. So I go to the library in my Epic Games launcher and I type Lyra, and I hit create project, and I created for 5.5 version of Unreal Engine. So let's wait while it's being created. Meanwhile, our true fighting game engine project has been started. At the meantime, let's enable some plugins in our fighting game project in Unreal Engine editor. So let's click the edit menu, go to plugins, and the first plugin we want to enable is named Pose Search. Let's find it and let's enable it. The editor prompts us to restart, but let's first enable two more plugins. Let's search for trajectory, and we enabled this motion trajectory plugin. It is experimental, and yes, we agree to enable it. And the third one is named chooser, and we enabled this as well, and now we can restart the project. At the meantime, our Lyra starter game project has been created, so let's open it up. So we open up our Lyra starter game project, we open our content drawer, and as we want to export animations, we navigate to characters folder, heroes, mannequin, as it is for our UE5 skeleton, animations, locomotion, unarmed. We are going to first migrate it with the Lyra skeleton, but later we will replace this skeleton with our default fighting game UE5 skeleton. So inside this unarmed folder we press Ctrl A to select all of the animations. First let's filter our assets by animation sequence type. So we only want to export animation sequences. So we select any of the animations and we press Ctrl A to select them all. We right click on the animations, we navigate to the asset actions in the pop-up menu and we go to the migrate option, and we can actually migrate it with its default settings, but I actually do not want to export any modifiers, any notifies, and let's see what we have. And we actually don't want effects. We could also disable materials and other things, but let's leave it as is. We press the OK button and we select our project folder for our newly created True Fighting Game engine project. And inside of that folder we select the content folder and we wait while our animations and other stuff is being migrated. Great, and our assets have been migrated, so we may now close the Lyra starter game project and we open up our True Fighting Game project. And in our fighting game project, let's open up the content drawer, go to content, and we see this characters folder that has been migrated from the Lyra starter game, and we open this folder and we navigate to heroes, mannequin, animations, locomotion, unarmed, and we see all these animations. Let's quickly replace the skeleton for all of them. So we press Ctrl A to select them all, we right click and we select the replace skeleton option. And what skeleton we want to set? We want to set this one as SK mannequin with the path at the game through FGE demo mannequins meshes. We select this skeleton and we press OK. Great, we save everything. Well, what we want to do now, with all the assets selected, we right click again and we select the asset actions and we edit selection in property matrix. In most of the tutorials you may see that people are enabling the root motion while they are working with the motion matching, but this actually depends. In our case we will disable the motion matching for all of the assets. At the left part of the table we have selected everything with the Ctrl A, but we force the root lock to be enabled and we can disable this option named use normalized root motion scale. And after we do these changes we save all. Now it's time to start creating our motion matching assets. So let's, in our content drawer, let's right click our content folder and create a new folder, and let's name it motion matching. And inside this folder what we are going to start with is we right click and we go to animation, and under the motion matching section we create a Pose Search Schema. And as the skeleton we select, we actually have two skeletons right now. We could delete that Lyra skeleton, but we didn't, so let's pay attention that we select the right SK mannequin skeleton, which is located in the game through FG demo mannequins folder. And let's name this newly created schema PSS underscore many and save it. And we are not actually going to modify it, at least for now. So we proceed right away and we create our databases. We right click and from the animation we navigate to our motion matching and we create our first Pose Search database. And as this schema, we have the only schema for now, so let's select this PSS menu schema and let's name it this newly created database PSD underscore locomotion. And let's really quickly duplicate it and name one more database PSD underscore jump and duplicate it as well and name it PSD underscore crouch. And now let's open up our PSD locomotion database and once again we go to characters, heroes, mannequin, animations, locomotion, unarmed. And you know what is, you may remember by default we have a queen fighter character in our fighting game selected, and it is very suitable that all the default locomotion animations have versions for mannequin female UE5 skeleton. So we just search for MF underscore in our unarmed animations, and as far as I remember, I may be wrong, but we will later fix this, we just drag all the animations started with the MF and we drop them to our database. We select them all, we see this entire set, and let's save them. Good. Now, well, I will just save this path because we are wanting to go back to our motion matching and open up our PSD crouch database, and we go back to our animations. I just paste the path here and I look for crouch animations. Sorry. And I select all the crouch animations and drag them into the crouch database. Right. Well, I'm going to rename this database. No, my English grammar is sometimes right. And we save. And now we open up our PSD jump database and we open up our content drawer and we go back to our animations folder and we search for jump, and we want to select them all, but then we select this one, unarmed jump recovery additive, and we drag them all and drop them into our PSD jump database and we save. Great, so we have these assets created, and let's now slightly modify our character blueprint. In our content drawer we navigate to the TrueFG blueprints and we open up our BP through FG base character. And first of all, in our components tab with the BP through FG base character selected, we hit this add button and we want to add trajectory component. We add this character trajectory, and that's good. Now we should check one thing. We select the character movement component. You know what, in our character movement I want to increase our max walk speed, because by default it is this value, but just for example I want you to see, I want to set it higher because we are going to use motion matching and we have those great jog animations, and I want to blend our walking with jogging, etc. So we increased this max walk speed to, I don't know, maybe 600, right? And we compile and we save. Now what we want to do, let's run the game, and let's replace the right character, the right fighter character of our fighting game, to use the UE5 queen skeleton as well, instead of the UE4 mannequin skeleton that is set by default. To do so, we go to our content drawer, we go to through FG blueprints folder, and we open up the game instance BP, and as we select from the variables tab the character right variable, and we change the character BP to be the BP through FG base character, and we change the mesh to be queen mesh, and we select this one, which is located in the true FG folder. Right, and now we also select our character right name variable, and let's change the name just to queen. And we compile and save, and yes, that's what I wanted to do. Now let's find the animation blueprint for our base fighter character. We open up our content drawer, and under the true FG demo characters we select the queen character, fighting animations, and we see this animation blueprint. Let's duplicate it, and just for clarity add to the end a suffix _mm, motion matching. Alright, and let's go back to our true FG blueprints folder and open our BP true FG character once again, and in the viewport we open up the viewport just for clarity, and we select the mesh component, and let's change its default animation BP to our newly created queen UE5 3D anim BP MM. So we will make changes not in the original blueprint, animation blueprint, but we will be changing its copy. Alright, let's save all. Now let's open this newly created animation BP, and we go to the anim graph, and you see all this logic, but let's scroll to the left, and you see before this layered blend per bone node we have these two input poses, movement and the cached idle pose. So let's just detach the movement node, break this link, and as instead of this input we are going to use our motion matching. First of all, let's do it without any choosers, just for our, and without jumping and crouching, just for our locomotion database. Let's right click on the empty space and let's search for motion matching, and we select this motion matching under the Pose Search, and as the database we select our PSD locomotion. Right, and at the right of this let's right click, and now we want to add a Pose Search history. So we right click and type Pose Search, and we add this Pose history node. We connect them, and if we do so and we compile, we actually can see our idle animation. But what we want, as we didn't set the trajectory yet, let's see, if we run the game, we only have our idle pose. But when we press our movement keys, we don't see any other animations. So we want to set up our trajectory for the pose history. So we right click the pose history node, and we right click the trajectory, and we see this binding pin option, but instead of this we are going to select this owner character trajectory, right? And let's see what happens now. And yes, it was that simple actually. But yes, you see, it can our character can jog, can walk, can change direction. Well, the crouch animation is still from our old state machine. It kind of works. Well, you know, I like motion matching, but it requires a lot of tweaks. You see? Well, so we have basically set this up. Let's do, you know what? In the animation blueprint for our fighter character, we have a separate state machine and a separate logic for the crouch movement. So before we start creating a chooser to choose between jumping and locomotion database, let's copy these two nodes and go here and paste them, and we will try to quickly implement the crouch movement as well. So we connected to this hit slot instead of our crouch movement output, but in this motion matching node we of course want to select the PSD crouch database, and I compile and I save, and let's see what happens now. And I press this crouch button, and yes, the crouching works, you know. I'm not to say surprised. Alright. I know this simple logic, but when it comes to first meeting the motion matching, Sometimes you can be surprised with a pretty unpredictable behavior. And now we want to create a chooser to also implement our logic for jumping. Let's really quickly look what we have in our event graph for our animation BP. Well, and you know, we actually have here the this is in air variable, which is set from the is fallen by using the is fallen function of the character movement component. So we are going to utilize this variable when choosing between our databases of locomotion and jumping database. So let's go to our motion matching folder and let's right click. And you see, if you have followed tutorials for the 5.4 version of Unreal Engine, looks pretty similar, but there is a difference. We right click and we search for chooser, and let's select this chooser table from the miscellaneous, and as the chooser type we are going to select a generic chooser. Well, and here at this step we want our result to be an object of type, and it should have a type of our database. So we look for Pose Search database and set. And let's first create and that look into it. Let's name it CT, which stands for chooser table underscore movement data basis. Alright, it is for movement and jumping. Well, and let's now set parameters. And you know, we are actually going to set an output parameter of our Pose Search database type. Direction output. Right. And we want to add an input parameter which will have type of our animation BP blueprint. And we search for our queen UE5 3D anim BP motion matching, and we want to use it as an input parameter, and we save and we add a row. Let's try to add an asset and one more row and the same, and as the result, as the first option we select our locomotion database, which we are already using in our animation blueprint, but we will replace this logic. And as the second result, we select this PSD jump database. Let's save. And now let's add column, and let's add a boolean, and let's bind it to our variable from our animation BP blueprint, that is why we are using this as an input parameter. And we are going to make choice basing on this is in air Boolean variable, and we are going to return our PSD locomotion database if it is set to false, if we are not jumping or falling, and we are going to return our PSD jump database if it is set to true. And let's save it. Well, but you know what? Let's rename this chooser table to be named CT mainly, because we may want later to do different choosers for different skeletons or characters, and it will actually be easier to operate with this. So now let's open up our animation blueprint again, and let's go to anim graph, and let's go here where we have our motion matching logic for our main locomotion, and let's select the motion matching node, and at the right in the details tab we see this settings section, and we see here this database field, and we set it to be the dynamic value, and we uncheck the expose on pin option. And what we want to do, we want to override to bind the on update function with a new one. All right, so here inside this new on update function we drag a connection from the input execution pin, and we search for a node named evaluate chooser, and we select this node, and as the chooser we select the CT mini chooser table, and this is the only our chooser table for now. And as the input for this we just provide a reference to self, right? And from this node output pin let's drag a connection and type convert motion, and use this convert to motion matching node function. Now from here we drag a connection and we type set database to search, all right, and we connect this, and we connect this motion matching node output pin to this input pin, and we connect our execution pin, and as the interrupt mode we select this interrupt on database change option. And you know what? We actually have this input parameter pose search database in our chooser table. Let's check it out. I think we have I don't know, we actually have this as a parameter, but I wanted it as an output parameter. What if we delete it? And yes, it seems we actually don't want that parameter, because you see we actually hear our result and we have the type of result, this Pose Search database, and we actually do have it. So let's compile and let's save. And now let's go back to our anim graph, And it seems like it could be it. Let's check it out. Let's run the game. No. Nothing happens. Nothing happens, and that's what I mean, that sometimes we can see some unpredictable results. But let's see what happens. Let's go to our city many chooser table once again. And what? No property bound to this is in there. Why? Let's click to it and try once again. And we save. Maybe because we have deleted that parameter. Whoa! And you see, it works now. What a great engine I love. I absolutely enjoy Unreal Engine. But it works. So, you see this?